Ini soalan additional exercise page 137 number 3B. Given 2 point charges Q1 are placed at point X and Y, means this positive Q1 is placed at point X. So then put the point charge here, and a negative point charge, which is Q2, is placed at point Y. So means here is our point, another point charge. What they ask us to find potential difference means, okay, so if I see this keyword means sure we have symbol for delta, means either we find, because here they not yet specify which one they want, but if I look further on Roman 2, they will try to move a charge from S to R, means R as the final point, right? Okay, so for this one we always use V final minus V initial. Alright, so V final means point R dot minus Vs. So we find this one, okay, so that easier for us to use the value for the delta V here to apply in Roman 2. Okay? But the problem is how we are going to find VR. Okay? At the point VR, remember, in the electric field, at any point in the electric field, actually there is certain value for the electric potential, right? But for this point, for example VR, okay, at this point, the electric potential actually influenced by not only this point charge, it is also influenced by this one, right? But do you need to draw a direction for electric potential? No need. In order to find VR, remember the equation will be KQ over R. But now is it we just have a point charge? No, we do have another. So always add on, always sum up another term which is KQ over R as well. Alright, so this one, okay, what should I substitute? Will be Q for, which is Q1, and the R will be from, you see here, our main character here R, from R to X, so this one will be Rx. How about this? Another point charge is actually from, okay, from Q2, and the R, okay, the distance is actually measured from where? From R to Y. Okay, so you have to know what is the value for the RY later. So that's how we know, how we calculate electric potential at point R. So let's substitute. K 9 exponent 9, Q1 8 exponent negative 6 divided by R, which is the distance between R and X, is actually 9 cm here, 9 cm. But centi stands for power negative 2, right? Okay, and plus 9 exponent 9 Q2. Sign of the charge, do we have to substitute in? Yes, must. It's a must to substitute in the sign here, okay, and the distance R to Y, I found that if this one 9, this one 8, how am I going to know this distance? In order to know the distance of the RY, I have to use theorem Pythagoras, okay. Here the length here 9, right, plus with 8 right? So what do I get here? 12.04 meter. So this one is the distance that I should substitute in here. Alright. So here, why the sign of the point charge have to substitute in? Because here this negative doesn't indicate the direction. This negative is the value for the electric potential. Okay, because it's scalar. Negatif di sini bukan maksudnya direction, bukan menunjukkan arah. Scalar quantity has no direction, right? So the sign must substitute in. Okay, so the answer for this one, okay, you calculate yourself. The unit will be watt. Okay, and we find the value for the second one. How I'm going to find Vs? The electric potential at this point is actually influenced by both point charge here also. So you are not only have KQ1 over R, I have to add on KQ2 over R as well. Okay. And remember, if I want to find Vs, the distance I should measure start from S. Okay. From S to the point charge 1, this one will be SX. And how about this one? This one will be from SY. Alright, then substitute in the value Q1 8 exponent negative 6. Distance, okay, distance 6. Don't forget multiple of the centi exponent negative 2, and this one add on 9 exponent 9 negative 5 exponent negative 6 divided by, as we know in mathematics SPM, if this one 6, this one 8, this one should be 10, right? If you don't know why this one 10 cm, then you can use theorem Pythagoras. Okay, the distance between SY you boleh guna theorem Pythagoras je. Okay, so from here you will get 10 cm, 10 cm, and from here you can find the watts here. So if I substitute in both value here in here, okay, so what is the value that you can get? You get this watt. Okay, so that's how we find the value of Roman 1. So this one a tricky question, you should know how to solve. Then we continue on for Roman 2. How I'm going to find work required to move a charge from S to R. So if I transfer a charge from a point to another, alright, so remember I always have to use a definition for potential difference. Kalau di sini adalah from infinity to R, then you just use definition for V. Okay, V, electric potential. Tapi kalau melibatkan from a point to another point, where these 2 points also in electric field, then we will use this concept. Tau V actually equals to work done divided by Q naught. Ini memang definition delta V. Okay, jadi untuk kita kira work done, guna je charge yang kita bawa atau charge yang kita transfer darab dengan delta V je. Okay, apa nilai charge yang kita Q naught yang kita pindahkan? 2 micro. Micro stand for power of negative 6. And what is the value for the delta V? Negative. Okay, kalau di sini ada negative, bawa je negative sign ni ke sini. Right? So here, kalau you cuba selesaikan ni, you get this answer. Okay, so that's all for this video.